students, today's topic based on line integral. So I think all of you have idea about definite integral, and if I consider this definite integral, integration over a to b fx dx, and you know that the geometrical interpretation of this definite integral is it gives the area bounded by x-axis x equal to a straight line, x equal to b straight line, and the given function. Now, if I consider this is the xy plane, this is x, this is y axis, and if I consider this is the given function, here it is x equal to a, and if I consider this is x equal to b, and this is the function fx. Now, we consider this is the point P, this is the point Q, and this is point R, this is point S. What is the area of PQRS? So we consider here smaller area, and I consider this smaller area is delta A. So I consider this distance is x. This distance is x, and I consider this distance is smaller increment of x, and therefore this distance is x plus delta x. So this length will be f of x, and this length will be f of x plus delta x. What will be the area of delta A? It is like trapezium. So delta A will be half of parallel lines. Parallel lines here, f of x plus f of x plus delta x, and distance between the parallel lines. Distance between these parallel lines here, it is delta x. Now we consider delta A, delta x is half of f of x plus f of x plus delta x. Now if I consider limit delta x tends to 0, then it will be limit delta x tends to 0 half of fx plus f of x plus delta x. So it will be dA dx, and when delta x tends to 0, so f of x plus delta x will be fx. So fx plus fx, it gives you 2fx, and finally half of 2x, you get f of x. Now we check rate of change of area with respect to x is the given function fx. And how you find this area? A. If I consider integration over x equal to a to x equal to b, then we get the area, If I integrate dA over x equal to a to x equal to b, here it gives the area of here it gives the area of here it gives the area of from left side from left hand side we get the area of PQRS and it will be a to b fx dx. So finally we get integration over a to b fx dx is the area of PQRS. And what is the area of PQRS? It is the area bounded by x equal to a, x equal to b, and x-axis and the given function. Now, if I consider function of several variables, here x and y are two independent variables. Now, if I try to plot this function of several variables, then it gives you a three-dimensional figure. Here I consider this is y-axis, this is x-axis, and this is z-axis. Now I consider a curve in xy plane, curve in xy plane. So any curve in xy plane, you can write y equal to gx, because any curve in xy plane, you can write y equal to g of x, and where y is dependent variable and x is independent variable. So I consider this is the curve y equal to gx in xy plane, and I consider here the point is x0 y0 initial point, and I consider the terminal point x1 y1. Now for x0 y0, for the point x0 y0, it lies on xy plane. So for x0 y0, we get a z0 in this figure. Why? We consider the function of several variables f of xy, that is basically z equal to f of xy. And if I put here x0 y0 instead of x, so we get a point z0 in the three-dimensional figure. Similarly, if I put here x equal to y1, x1, y1, if I put here x1, y1 in that function, we will get a z1, and z1 is basically f of x1, y1, I consider. So this will be z1. And if I consider all the points along this curve, then we will get some z here. And if I connect this, there will be a curve. And is there any relation between this curve and this curve? This curve is on, this curve is in the three-dimensional figure, and this curve is on xy plane. So this curve is basically the curve on xy plane is basically the projection of this curve in xy plane. The curve y equal to gx is the projection of this curve in xy plane. Now, if I connect all these points, this curve and this curve, we will get a surface. We will get a surface. So, what will be the area of this surface? So, to find this To find the area of this surface, we consider here this is the smaller area, delta A. I consider this smaller area is delta A. And I consider this point is x comma y. And here I consider this point is x comma delta x. I consider the smaller increment along this curve, and I consider this is x plus delta x comma y plus delta y. Okay. So what will be the length? This length will be f of xy, and this length will be f of x plus delta x comma y plus delta y. So what will be the area of this? What will be the area delta A? So delta A will be, it will be like trapezium, half of f of x comma y plus f of x plus delta x comma y plus delta y multiplied by this distance, multiplied by this distance. What is the distance? If I try to plot this curve in xy plane, here we write this is x comma y, this is x plus delta x comma y plus delta x, y plus delta x, sorry, y plus delta y. So it will be delta x and it will be delta y. And I consider this is the increment, smaller increment along this curve. So if I consider this is delta s, so we multiplied by this length delta s. We multiply by this length delta s. What is delta s here? Delta s will be root over del x square plus del y square. Okay. Now, if I divide by delta s, it will be half f of x plus f of x plus delta x y plus delta y. Now, if I consider limit delta s tends to 0, del a del s, it will be limit del s tends to 0, half of f of x comma y plus f of x plus del x comma y plus del y. Now, this will be, this will be DADS. And when del s tends to 0, that means del s tends to 0 means, here you check, del s tends to 0 means, whenever del s tends to 0, that means del x tends to 0 as well as del y tends to 0. So from the right hand side, we will get half of f del x tends to 0 and del y tends to 0. So here we get from this, we get f of xy, and f of xy plus f of xy, it will be 2 f of xy, and half of 2 f xy we get. Now check rate of change of area with respect to arc length is the given function. Here, rate of change of this area with respect to the arc length s is the given function f of xy. Now, how we get the whole area? If I consider this is the P point, here Q point, here it is R, and here it is S. Now, if I integrate it x0, y0 to x1, y1, x0, y0, x1, y1, f of xy ds. And area of this will be the area of PQ RS, and it will be integration over x0, y0 to x1, y1, f of xy ds. And this is called the line integral of the function f of xy along this line or along this curve y equal to gx, where the initial point in this curve is x0, y0, and terminal point in this curve is x1, y1. And this is called the line integral of the function f of xy along this curve. And line integral gives area. Line integral gives here the area. Is there any similarity between this line integral and this definite integral? Also, there is similarity. This is also a line integral. Here is the line is x-axis, and here it gives the area bounded by x equal to a, bounded by x equal to b, and x-axis and the given function. Here also it gives the area. Now look at this line integral x0, y0, x1, y1, f of xy ds. And what I get? Del s equal to del x square del y square root over del x square plus del y. So we write ds will be root over dx square plus dy square. So write here x0, y0 to x1, y1, f of x comma y root over dx square plus dy square. Now check, here is two variable present, x and y. How to integrate these types of line integral? So for every curve in xy plane, here we consider for this example y equal to gx with the curve in xy plane. For every curve in xy plane, we get parametric equation corresponding to the curve. Suppose we consider given curve is y square equal to x. So parametric equation of this curve will be x equal to t square, y equal to t. Suppose it is given that the curve is x square plus y square equal to 1. So parametric form of this curve will be x equal to cos t, y equal to sin t, and where t is the parameter. So here we consider the curve is y equal to gx. So for this curve, we will get a parametric equation corresponding to this curve. So I consider the parametric equation of this curve is x equal to h of t and y equal to t of t. You check here x is function of t and y is also function of t. You can here check x is function of t and y is function of t. T is the parameter, and in general we consider here x is function of t and that is ht here, and y is function of t, that is kt here. So dx will be h dash t dt, and here dy will be k dash t dt. And for x0 y0 and for x equal to x0 and y equal to y0, we get a t, and that is t equal to t0. Why? Because for this problem, if I consider x equal to 1 and y equal to 1, so we get t square equal to 1 and t equal to 1, and combining this we'll get t equal to 1, because from this line it gives t equal to plus minus 1, from this it gives t equal to plus 1, and both equation is satisfied by the value of t equal to 1. So for x equal to 1 and y equal to 1, we get a value of t equal to 1. So here for x equal to x0 and y equal to y0, we get a value of t. I consider this is t0. Similarly, when x equal to x1 and y equal to y1, we will get a value t, and that is t1. So finally, we write here t0 to t1 f of x means here h of t, y means k of t, and dx means h dash t dt square plus k dash t dt square, and finally we'll get here t0 to t1 f of h t comma kt, and here it will be h dash t square plus k dash t square and dt. Now we'll check only parameter is involved here, t. Now you can easily integrate this and you can get the value.